Hello guys to this tutorial about the stepwise regression approach. You remember that in multiple linear regression we have several independent variables to predict the dependent variable. And you remember that some of the variables could not be significant. Some of them are insignificant. And these variables, if these variables stay in our regression model, they will give us a wrong model, not powerful model. So we should get rid of the insignificant variables from our model. To do that, we have an approach, we call it stepwise. In this stepwise method, we only keep the significant variables in our multiple linear regression. These variables will improve the regression model and we'll remove the other insignificant ones. So, stepwise regression approach can be divided into two methods. The first one is forward selection, and the second one is the backward elimination. The forward selection is start with no variables in the model, and start adding one by one, and start testing each one by checking the significancy of that variable through checking the p-value. If you remember from the previous lectures when we used p-value and also checking r-squared to find out if the variable is significant and if the model is really represent the variance of the change of the values. So in other words, we are checking p-value and r-squared. Then, if this variable is significant, we will keep it and add another one. If it's not significant, we'll remove it and add the next one. So it is stepwise, it's one by one. So we'll keep adding and removing until finally we'll end up with only the significant variables in our model. We'll use that model for prediction. So let's take this example to understand what I mean. Let's, for example, I started with one variable here, which is x1. And I try now, after I run the regression model, I want to find out if this variable is significant or insignificant by checking p-value of the variable. So if the p-value is less than or equal to 5%, that means this variable is significant. And also I will keep my eyes on the r-squared to see what is the r-squared or the adjusted r-squared. Just remember this value. And let's assume that the b1 or sorry the x1 is significant. This variable is significant. So we'll keep it and add x2. And again, I will check the p-value of this variable and see the r-square, if the r-square is getting up or down. And you remember that r-square is the value that's showing us how the regression model represents the changes or the variance of our data. So the higher the r-squared or the adjusted chi-square, the better the regression model prediction power. And let's say that we found this time that this variable x2 is insignificant. So that means we need to remove it because its p-value is greater than 5%. And we added now x3. And let's find also what is the p-value of the x3 and what is the value of the r-squared or adjusted r-squared. And we found this time the x3 is significant, and also we found that the r-squared is improved, assuming that adding a new variable, it also this variable is significant, but also increased or improved the value of r-squared. So in this case, we tested all our three variables that we have, and this is our final prediction model. We only kept x1 and x3 because both of them are significant and they improve the value of r or adjusted r-squared. We call this method, as you remember, the forward selection because we keep adding the variables one by one. The second method is the backward elimination. And in this method, we start with all candidate variables in the model and start eliminating them one by one if they are insignificant. So we start removing the insignificant variables that has the highest p values from. So let's say that when we run the model, we found that 2 variables are insignificant. So which one we are going to remove first? We will remove the one that has the highest p value first and run the model again. And we keep doing that, repeating this process until removing all the insignificant variables from the model and keep the ones only that improve the model. And after that, we'll use that model for prediction. So let's take the same example that we started first with all the variables now, x1, x2, and x3. And we run the regression model and we tested these values, and we found here that these 2 variables are insignificant, x1 and x2. But we found that the p-value of x2 is the greatest, is the highest one. So we remove x2 from our regression model and we run it again. And we check again the r-squared and the p-value of our variables. And we found this time that both of them are significant, x1 and x3. And also we found that r-squared now is better. R-squared or adjusted r-squared better than the previous r-squared, with these also 2 significant variables in the model. So we decided this time to keep both of them and use this model for prediction. And we call this method, again, we call it the backward elimination. And we are going to use this method in our multiple linear regression when we create multiple linear regression, because it's more straightforward. Because you put all your variables and you will start taking the ones that we found them insignificant.